In this video, we're going to be looking at molar mass. Now, molar mass is the mass of 1 mole of substance. So that would be the definition. So it's the mass of 1 mole of substance. So remember, a mole is 6.022 times 10 to the 23rd particles. So if it's a compound, like water, so water is H2O, so it has 2 hydrogens and an oxygen. A mole of water would have 6.022 times 10 to the 23rd water molecules. If we're looking at an element like carbon, a mole of carbon would be 6.022 times 10 to the 23rd carbon atoms. So a mole is always the same number of stuff. So when we look at molar mass, we're looking at if we have 1 mole of that substance, what is its mass going to be? Now the units for molar mass are grams per mole. So this is saying in 1 mole of substance, it has so many grams. So usually we see this abbreviated as G/MOL. So those are the units for molar mass. When we go to calculate molar mass, we're going to use our periodic table. And so I have just the box for hydrogen here on the board. The number that you're going to be using off the periodic table, because there are 2 for each element. There's a number at the top. That number is going to be a whole number, and it's going to go in numerical order as you go through the periodic table. We're going to talk more about what that number means in another unit. The number we're going to be focusing on right now is this number here at the bottom. So that number tells you the mass of 1 atom of that element, or it tells you the mass of 1 mole of that element. So this is the number that we're going to use to calculate molar mass. So let's look at some examples, because that's the easiest way to figure out how to do this. Our first example is pretty straightforward. Find the molar mass of fluorine. So if we go to our periodic table, and we find fluorine on our periodic table. Now, when I find fluorine, there's a 9 and there's an 18.998. Now, the 18.998 is the number at the bottom, so that's going to be the mass. So our molar mass of fluorine is 18.998 grams per mole. That's it. That's all it is. Okay, let's look at our next example. So we have O2. So we have 2 oxygens bonded together. So we can't just take the mass of 1 oxygen. So we're going to take this number, so we're going to take our 2, and we're going to multiply it by the mass of our oxygen. And the mass of our oxygen is 15.999. Again, I got that from the periodic table. So when I do 2 times 15.999, so I'm going to use my calculator, I get 31.998 grams per mole, and that's the molar mass of O2. Let's look at our third example, NaCl, or sodium chloride. So this compound is made up of a sodium and a chlorine. So we're going to need to add the mass of those 2 things together. So we have 1 sodium. The mass of a sodium is 22.990. And we're going to add to that the mass of our chlorine. So the mass of our chlorine is 35.453. So since I have 1 sodium and 1 chlorine, I add those 2 masses together. So I get the molar mass to be 58.443 grams per mole. And that's the molar mass of sodium chloride. Our next example is hydrogen peroxide, or H2O2. So this has not only 2 different elements, but it also has 2 of each of them. So we need to account for 2 hydrogens, and we need to account for 2 oxygens. So we're going to do 2 times the mass of hydrogen. And the mass of hydrogen is 1.0079. So this is 2 hydrogens. And then we're going to add to that 2 oxygens. So 2 times 15.999. So that's our 2 oxygens. That's an O, not a 0, so it's not 20, that's 2 oxygens. So we're going to add those together. And I get 34.0138 grams per mole. And that's the molar mass of H2O2. So these are all relatively straightforward. Let's look at 2 examples that are just a little bit more complicated. Okay, so for this example, we have calcium hydroxide. So this formula looks a little bit different because we have parentheses. So parentheses do similar things in chemistry and formulas that they do when we think about parentheses in math class. So what's on the outside of the parentheses applies to everything inside. So we have 1 calcium. We know that we have 1 calcium because there's no subscript right here. So we're going to have a calcium. Now we have OH in parentheses with a 2 on the outside. So that means we're going to have 2 oxygens and we're going to have 2 hydrogens all added together. Now once you've kind of figured that out and you've deciphered all the pieces, it's the same as before. So we just have to add all those masses together. So the mass of calcium is 40.078. And then we have 2 oxygens. Oxygen is 15.999, and then we have 2 hydrogens, so 1.0079. And we'll add all of those up. And we get 74.0918 grams per mole. Okay, let's look at just one more example. Now this formula is a specific formula for a specific type of compound called a hydrate. A hydrate simply means that the compound has water molecules attached to it. So for here, we have calcium sulfate, so CaSO4, and for every one of those, we're going to have 3 water molecules attached to it. So this dot here does not mean to multiply. Normally when we see dots in math class like that, it means we're going to multiply those 2 things. We're not multiplying here, we're just adding them together. That's just the way the formula is written, so all you have to do is add up all of the pieces. So if we decipher this, so we have 1 calcium, we have 1 sulfur, we have 4 oxygens. And then to that, we're going to have 3 waters. So if we have 3 waters, that means we're going to have 6 hydrogens. So if we have H2O 3 times, that means 2, 4, 6. We have 6 hydrogens. And then we have 1, 2, 3 oxygens. So now we're going to put all the masses in and just add them all up. So calcium is 40.078. Sulfur is 32.065. We have 4 oxygens. We have 6 hydrogens. And then we have 3 more oxygens. Okay, now we're going to put all of that into our calculator. And we get a molar mass of 190.1834 grams per mole. Now, a couple of things. Remember to leave the rounding until the very end. So your quiz or your test or your homework will tell you whether to round to 2 or 3 or 1, however many decimal places it wants you to round to. So pay attention to that, but remember, don't round until the very end of the problem. So you can put all of this into your calculator at once. That way you don't have to round in between.